Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, we are going to discuss the different kinds of MCQs which are asked in the previous GATE examination and which are asked in some of the competitive examinations and some of the questions I designed which are to be asked in the next GATE examination or next competitive examinations. So before entering into the decision, let us say all our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has created a wonderful interface to serve the dedicated students with top quality content. You all may use them just by giving your valuable admission into Unacademy. So once you get the admission into Unacademy, then your goal is already fulfilled because your goal is Unacademy's goal. Dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with various papers. Throughout my journey of GATE, I taught in many premium academies with a high success rate. So friends, also had industry experience in the back-end side. So many of my students got completed their post-graduation from India's topmost institutions like IITs and IITs, and they settled in their life in the higher positions. You also can just by giving a prestigious competitive examination, nothing but a GATE. And once you prepare for GATE examination, this preparation is also eligible for to write any kind of competitive examinations like ISRO, BARC, and others. Friends, in order to get the admission into Unacademy, there are two programs according to GATE and ESE consent. Number one, plus program. The second one is iconic subscription. Once you become a subscriber to Unacademy, then you're going to access the Unacademy portal unrestrictedly. Therefore, you can access live lessons like quizzes, mock sessions, and many other things you can able to access. And Iconic Batch is a unique program which is in Unacademy where you're going to get a plus inbuilt, and the second you're also going to access 1:1 personal coach. Therefore, friends, utilize this unique program so that you're going to get 1:1 interaction programs in the technical side and any kind of lectures. And according to Plus courses, these are the subscriptions, friends. So if you use my referral code, you're going to get a maximum concession, and a 12-month subscription, fourth year students can opt, and 24-month subscription, first and second and third year students can opt, and second and third year students can prefer for 18-month subscription. And once you use my referral code, then you're going to see that maximum concession on the above subscription prices. So these are the prices after using my referral code. And the other one is iconic subscription. I already told you the use of iconic where you're going to get the 1:1 interaction. There are current fourth year students can prefer this. Second, third, and first year students can prefer super long term iconic plan. So use my referral code to get the admission into Unacademy, either into Plus or Iconic. And you're going to see that the maximum amount of concession in Iconic also. And friends, I would like to say that my referral code is also eligible for any kind of a program, not only for GATE and ESE. You share my referral code to all your friends. Therefore, I can able to act as their guide also because they are all going to join under me once you use my referral code. Let us start our today's session. Our today's session is the different kinds of questions which are being given earlier and which are to be done in the upcoming years. Let us pass. So he is given some ER diagram. So we want to identify minimum number of tables. Please remember, maximum number of tables different from minimum number of tables. So while you are doing your ER into relational model, we want to do some kind of reduction. Reduction of your design while construction of your design into relational model, you can able to minimize them. Some of the redundant entities, some of the redundant relationships, some are unnecessary attributes. So you can able to remove them. That's the meaning of minimization. So according to this structure concern, how many tables are required while you are converting your ER into relational model? Friends, so according to our rules, what we learned last session, that entity must be created. Either a strong entity or weak entity, associative entity, all the three entities we want. Here, this is the strong entity as EID is been underlined. So create one strong entity, so one table, and a salary and EID and ename are the normal columns, but address is a multi-value and phone number is a multi-value. So when you see that they are the multi-value attributes, we know how to do this. So altogether, there is a requirement of what? Three tables. And what is a table structure? The table structure, every time please learn how to write the table structure. The emp consists of EID and a sal and ename. Now the second question is like this. Every student has to register a course. So what is the constraint to be used in ER diagram to implement the above requirement? Compulsion. Every student has to register a course. When you say compulsion like this, must register, every student must register for course means employee. So one table is a student instance and the other instance is a course instance, and we are making a compulsion to the students to take the admission in such case. And you can go for this terminology. You know what is this terminology. So if it is optional, you know what is the terminology. So let us see another question. So we want to answer this. Entity set, collection of similar entities of recording one kind of information system, which may be employee recording system, which may be departments, which may be course recording system. So entity set is nothing but collection of entities that have the similar sets. Entity is an object which is to be identified uniquely. Weak entity is identified with a partial key. And weak entity and composite attribute you can take it as address, because address can be further split into door number and flat number, street, city. According to that, your answer is 4C. This is your answer. So you also please solve at your side so that you will also have confidence while solving the questions. So the primary key of an entity set formed by the identifying an entity set plus weak entity set. So the primary key of an entity set formed by identifying an entity set plus the weak entity set. What is it? This is a department entity. This is employee entity. And both are trying to participate in the relation is observed. As a department has got a department number and employee has got a partial key, something like employee name. Now therefore, this is a weak entity because which has got weak attribute, and this is a strong entity. Therefore, you need to have, because as to maintain the data uniquely in employee table, you need to have what? Your weak key and plus your depending on strong attribute of others. So others is nothing but what? DNO, which we are calling it as FK, and this is going to be here as what? PK. So which is nothing but what? Your partial key. Together with this, we are going to maintain a what? Uniqueness. So it is nothing but primary key of a strong entity and a discriminator of your weak entity set. So discriminator is nothing but partial key. Once look at next question. ER model weak entity meets which of the following condition? So weak entity is an existency dependency. Perfect. Weak entity has a primary key. No. Weak entity has a primary key that is a partially or a totally derived from the parent entity in the relationship. So weak entity has a primary key that is a partially or totally derived from the parent entity in the relationship. So we also go for this because using the parent entity with the help of discriminator, you can able to go for it. So if we represent the following business rule in relational model, which of the following constraints are not required? Each professor teaches at most one course. Each professor teaches at most one course means, so only one course, right? Each professor teaches at most one course. What it is? Is it a partial participation or is it a total participation or it is a key constraint? We want to see that he is supposed to teach only what? One course. That means duplicates are not allowed, which indirectly telling you that duplicates are not allowed. When you say that duplicates are not allowed, I can answer for it as a key constraint. Otherwise, I can also call it as what? Cardinality constraint. So there we are going to specify. There we are going to specify that the other side, what is the cardinality? So this is your answer, cardinality constraint. So what is the cardinality constraint? You take that professor and a course, and each professor can take at most one course. So maximum cardinality is a 1. So consider a business rule. Each department is managed by at most one employee. At most one employee. So each department is managed by at most one employee. One means only one. So every department can be managed by at most one employee. So when you look at, if there is a relationship with a 1:m, 1:m is the relationship. So there are two entities, X and Y. So I'm giving you complete description, don't worry. This is the first point. So relationship between your X and Y is a 1:m. X is a one side y is a many side. So what is the meaning of that? So there is a requirement of what? ER diagram to be converted into relational model. So what to do? We are trying to do merging y with m. That means how are you going to do the merging? Last session I shown you. The pk is going to be act as here fk. So y is going to be manipulated. How? Change y side to x foreign key as a primary key, or change y side to x is a primary key as a foreign key. So option B and D you are in a position to identify. So what are we going to do? X primary key we are going to attach to y. So add x primary key as a foreign key into y side. The next one. Observe the following ER diagrams. Student enroll courses 1n. Student enroll courses n1. So cardinality of student is a n. That means a student can take more than one course. So one student can enroll to many courses, but one course will have only one student. Yes, this is perfect. The course cardinality is a 1. A course can have only one student, but a student can enroll into many courses. Second statement. Student enrolls for only one course, but a course can have many students. This is wrong. Both ER1 and ER2 will give same meaning. No. So the option A is a what? Correct. And both ER1 and ER2 will not give the same meaning. Yes, they are different. Why they are different? A student can take many courses according to ER1. According to ER2, a course can have many students, but a student can take only one course. So he is asking which of the wrong according to your ER1 and ER2. You can also answer. You can share your answer with me. So according to ER1, this is correct. One student can enroll to many courses, but one course will not have one student. And option B, according to ER2, student enrolls for only one course. Perfect. But course can have many students. Perfect. So D is also correct. Both ER1 and ER2 will not give what? Same meaning. An entity set may not have sufficient attributes to form a primary key. An entity E1 do not have a primary key. When it do not have a primary key, that is called as a what? Weak attribute. Weak attribute forms your entity to weak entity. In entity relationship, y and x, two entities are there. Y is a dominant entity. Y is a dominant entity. Dominant means it is a parent entity, and X is your subordinate entity. X is your subordinate entity. So this situation is called what? Existency dependency. This situation is called existency dependency. What is the meaning? Here, X is a completely depends on Y. Without Y, there is no use of X. That's the meaning. X is existence dependent on Y. Yes, this is correct. And if X is deleted, Y remains the same. If X is deleted, Y also deleted. This is wrong because as Y is a parent entity, if X deletes, nothing will happen. But if Y deletes, X is going to be deleted. This is also correct. If X is deleted, Y remains the same. Yes. So this is the incorrect one you need to choose. So student and courses is a concept of which kind of cardinality. In general, you can talk. In general example, this is when I am giving you that student enrolling for courses. So what is the meaning of that? A student can enroll into one course or many courses. And that's what he is asking. A student and enroll is an example of what? A student can enroll into what? One course or many courses. A student can enroll into what? Many courses. But you look at here, if I am taking an example that he is asking student and course is the entity and enroll is the relationship. Enroll is the relationship. Now listen. A student can take only one course, means a course can have only one student. It is a one-to-one. Naturally, there is no such kind of a restriction. A student can join for any number of courses. A course can have any number of students. So I can go in default that this is the correct answer. Both sides it is true. A student can take many courses and a course can have many students. In the relational model, number of attributes, for example, I say there is employee entity which are having employee number and which is having employee name and which is having age. The attributes are called, how many attributes are there? 3. So employee degree is 3. Employee degree is how much? 3. So number of attributes is called as what? Degree. And number of tuples are nothing but what? Cardinality. So columns speaks degree, tuple speaks cardinality. A relationship among entities of the same. This is superb. Employee has got the relationship itself. Employee has got the relationship is itself is called as what? Recursive relationship. So this one is very simple. We know many is to many can be decomposed into every m is a 1 and every m is a 1. So it is this. So what is a false? Every dominant is a strong. Perfect. A weak entity will not have a primary key its own. Yes, perfect. And a specialization is done when more than one domain constraint is required on an attribute based on an entity type. Option C, a relationship type can be related to another relationship type. This is wrong. Entity to relationship you can able to. Entity to entity you can have a relationship. So descriptive attributes are nothing but attributes which are belongs to the given relation, recording information about the relationship. Recording information about data is nothing but about entity. So what he is asking? Project and consultant, two tables. project and consultant. So what are the constraints he mentioned? Let us impose. A project can contain a minimum and maximum of only one consultant. A project can contain minimum and maximum of one consultant. And a consultant must handle minimum and maximum of only one project. A project can handle only one consultant, can handle by only one consultant. A consultant can handle only one project. So when you represent this, you got a situation. So how many tables you need to map? Project we need, consultant we need. This one, you know what to do. Only we are going to treat as associate entity. So remaining we are not going to create as a what? Separate entity in the relational. So one end relationship in an ER model is implemented. So one end means what? One side key will be added into many side foreign key. So relation corresponding to one side is modified include foreign key of the relation on the end side. So relation corresponding to one side is modified. No, that's wrong. End side is going to modify. And this is also wrong. And this is also wrong. So end side is modified to include the primary key of what? One side. A minimum cardinality of 0 specifies. When you talk about the relationship like this, now PP is nothing, minimum cardinality is 0. TP, minimum cardinality is a 1. So once look at this, consider the following ER. So E1 and E2, all simple and single attributes, all simple and single attributes. And this is your associate entity. So 3 tables. So department, employee, associative entity, 3 tables. So person owns a mobile number. So relationship is a owns, person is an entity, mobile number is an entity. So what is the meaning of that? A person may own any number of mobile numbers, but a mobile number can be owned by at most one person. Perfect. This is a n max. This is a 1 max. So once listen, a person may own, option B, let us check. A person may own any number of mobile numbers, but a mobile number can be owned by exactly one person. So, perfect. Each person may own one or more mobile numbers, and a mobile number can be owned by at most one person. Each person has to own exactly only one mobile number, and mobile number can be owned by any number of participants. This is wrong. So among three, which is the correct one, we want to see. So when you talk about the option C, you need to understand one important point, whether this is a partial participation or total participation. When you talk the total participation, every person, please understand, each person is the concept. According to TP, this is correct. According to PP, partial participation, a person may own, may or may not, any number of mobile numbers, but a mobile number can be owned by at most one person. This is exactly one person. So if it is a total participation, this is our answer. So if you look at this example, loan and a customer, and the relationship between them as a straight line. You know what is the meaning of straight lines. So therefore, how many entities we want to create? We want loan with a loan ID and amount. We want a customer with a customer ID and a customer name. And what is this relationship? Based on the relationship, only remaining table is going to have. I'm designating as MM. Therefore, you need to create payment. The payment consists of this side and this side as their keys. And your descriptive attribute, that is a paid date. So 1, 2, 3 are correct. So if you look at this is a 1M. So 1M in the sense how you are going to map them into relational model. Department we need department number and department name. Employee we need employee number and employee name. And this is M. So I'm going to do like this. You know what is the meaning of this. So therefore employee is going to be modified with the key column of LHS. So employee with the what? The number, and employee with the what? DOJ. So what is a false? The false is this is a false and this is a false. So what is incorrect? An attribute of an entity can have according to ER model and a relational model. This is your 2011 GATE question, 2012. According to ER and a relational model, he is asking us to compare. In ER, first point is about ER only. An attribute of an entity can have more than one value, perfect, multi-value. An attribute of an entity can be composite, fine, can derive. In a row of a relational table, an attribute can have more than one value. This is wrong. Because multi-values are not allowed according to the chord rule. In a row of a relational table, an attribute can have exactly one or null value. Perfect. So this is incorrect one. So when you talk about this, there is E1, there is a E2, and the relationship name is a 1M. And the attributes are, E1 attributes are A11, A12, and A13. E2 are A21, 22, A23. A23 is MVD. Now how many tables? He is asking find the number of tables. E1 is a mandatory, E2 is a mandatory, this is not mandatory, this is mandatory. So our answer is 3. And the next question is, E1 and E2 are two entities. So I am giving you a schematic diagram that is represented in the form of sentences. E1, E2 are two entities. And R1, R2 are two relationships. Yes, you can have any number of relationships, no problem, between two entities. R1, R2. R1 is one too many, R2 is many too many. Is asking number of tables. You know how many number of tables. E1 mandatory, E2 mandatory, this is mandatory, not required. So when you look at another question, hotel person, and the relationship name is MM. So based on this, there are two questions which are given in that year. Two questions are there. This is a question number 1. How many tables? 3. So I'm taking the same structure. This is a good question. If we wish to store information about rent to be made by persons, this guys, who are occupied in a different hotel room, this person, this guys, and this information, where are you going to store? And now you see, if I am taking a field like HID, hotel ID, if I am taking here person number, as this is a relationship, this will come here, this will come here. Now you got both the information together. What is that? A person occupying a different hotel rooms. So if I attach here, then it's one of the best suitable rent. I am paying the rent about the lodge who are occupied in a different hotel rooms, persons who are occupied in different hotel rooms. Therefore, your answer is lodge. This is a 28 IISc Bangalore question. Very good question this is. So by seeing the structure, don't get worried. At least bother about the structure. You bother about the rules. You know the rules how to map the table. Listen. We want M as M1 is a key. We want N as N1 is a weak key. And a weak entity this is, and strong entity this is. Right? And this is a total participation. And this is your weak relationship. This is a total participation. This is a strong relationship. This is a 1. This is the M. This is the M. This is a 1. That's it. And P1 is the key. Now if you answer, what is your answer? Your answer is, we want M, normal. Strong entity and weak entity you need to create. So M required, N also required, and P is also strong entity. So P also required. So what are your columns? Your columns are M1 in this, M2 in this, M3 in this. And your columns are N1 partial and N2. And your P is P1 and P2. Now, how many tables he is asking? So 1M we are not interested. So we will add this into that side. Please recollect my yesterday's lecture. And this is also 1M. We will not do. So add this into this side. So this is how you can get it, a structure. So how many tables? 3 tables according to this. So which of the correct attribute set? So I already written here attribute sets. You follow. Which of the correct attribute sets? M1, M2, M3. Yes, we want. This one we will bring here. Perfect. And remaining all are wrong. So if you look at this question, see the question is very, very lengthy. But the logic and rules are very simple as I told you. You can answer just by reading the question itself, you will get the answer. Let me read out. So in ER model, this is very latest gate question. E1, E2 are connected by M1 relationship. So let us take its ER. Immediately note it down. E1 and E2 are connected using Mn relationship by name R12. The relationship name is Mn. And next one, E1, E3 are connected by 1n. So one more entity is there. They are connected using 1n. E1 has two attributes A11, A12. A11 is the key. Now let us come to E2. E2 has A21, AT2. AT2 of which the key attribute. So A21 and A22. Now E3 has A31, A32. So this is the key. And E3 has A31, A32. Now what is asking? The relationship do not have any kind of descriptive attributes. He is asking find the minimum number of tables. So minimum number of tables, we know the rules. 1 and 2 and 3 and 4. That's it. This is your answer. See how simple if you know the rules well. Because strong entity, weak entity, associative entity you need to create. As this is a strong entity, as this is a strong entity, as this is a strong entity, as this is associate entity. So remaining not required. So 1, 2, 3, 4 is your answer. So if you look at another question, this is 2019 gate question. An ER model of a database consists A and B, two entities. So let me do the ER. A and B are two entities. They are connected by R, which does not have its own descriptive attributes. The relationship name is R. So under which of the following condition can the relation table R will be merged with A? I want to merge with A. This has to merge with A. So merge with A means you know. So R is going to merge with A means we are following a merge rule. So when are you going to do the merge? That should be 1 or M. You can decide. So merging a relationship is always with entity means is it a 1 or M means we can go for what? M. And the other one is a what? 1. So the he is asking the relationship only. So the relationship is a what? R is merged with A means. So M to 1. Please look at the diagram. It is a M to 1. So and the participation of A, E, R is a total. One more. Entity A is going to merge. Your relation is going to merge with your entity A. It can also be done using a what? Partial participation, no doubt. when it is under M1. So what is our answer? So M1, this and this is wrong. M1 either with the total participation or with the partial participation. Anything is correct. But the strongest one, because the total participation is always a weak. Total participation, whenever you say that, always it is a what? Dependent on others. Hence, examiner is looking that answer is a what? Total side. But both are correct. And this is a very latest question. Which of the following is used to represent the supporting of many to one relationship of a weak entity? Please understand. Many to one relationship of a weak entity set in an entity relationship diagram. So let me draw it. E1 and E2, and you are having the relationship like this, and his main intention is that weak entity set only. This is the weak entity set, and whenever weak entity set is participating in the relationship, it is called as a what? Weak relationship. This is your weak relationship. So WRS, WE, and this supposed to be SE. Therefore, he is asking many to one relationship means this is he is asking is that diamond with the double. And this is another question. So suppose R is a many to one relationship from entity 1 to entity 2. From entity 1 to entity 2, R is a relationship. This is your relationship. So assume both are participating totally. That is the second sentence. And the cardinality of E1 is a greater than the cardinality of E2. What is true according to this? What is true? And the relationship name is many to one. So underlined statements are very important. So now let us see many to one we want to write. This is M and this is a 1. Now you see what are you going to expect? We are going to expect in a such a way that the R is going to be depends on your E1. Right? So what is the sentences given? Let us cross check. Every entity in E1 is associated with exactly one entity in E2. Every entity in E1, every entity in E1. So this side to this side. Every entity in E1 is exactly associated with E2. Yes. Exactly associated with E2 only one time. Every entity in E1 is exactly associated with exactly one entity in E2. So this is correct. If you look at some entities only, no, it is not some entity because totally participation. Whenever you see that totally they are participated 100%, every entity should be participated. Therefore, some entities are wrong. It's not optional. If it is optional, it's a partial. So reverse. Every entity in E2, yes, every entity in E2 is associated with exactly one entity in E1. No, E2 can able to participate. How many? More than one. Therefore, this is also wrong. Next one. Every entity in E2 is associated with at most one entity in E1. Every entity in E2, at most means what? Maximum one. But it's at most M. Therefore, it's also gone. Well, friends, so our answer is what? A. So this is based on specialization. Specialization is nothing but top-bottom approach. Top-bottom approach is nothing but this is your parent class or parent entity, and these are your child entities called child entities or sub-entities. Whatever you inherited, whatever you implemented in employee in parent class, automatically they can be derived in subclasses. Whatever you implement in your parent class, automatically they will be inherited into your subclasses. So what they want is asking, manager is an employee, yes. Engineer is an employee, yes. Secretary is an employee, yes. Clear? That means every employee may not be a manager, every employee may not be engineer, every employee may not be a secretary. It is not a overlapping. It is a covering. What's a covering? A manager is an employee, an engineering is an employee, a secretary is an employee. Reverse is not true. An employee may be either of the category. So every employee belongs to different categories and their salary is based on their category of the job. If it is a manager, he will earn something. If it is engineer, he will earn something. If he is a secretary, he will earn more than these two. According to their position, the salaries are going to be calculated. And now what are implemented in your superclass? What are implemented in your subclass? We will see. The function get name and get ID, compute salary are required. So three functions we want to calculate. One function is get name. Other function is get ID. Other function is compute salary. But please understand, if you use a get name function in the superclass, that I can derive in the subclasses. Because a manager has got a name and a manager has got ID. If you implement your get ID in your superclass, automatically I can able to derive. Because these subclasses are deriving on your parent class, inheriting the properties. So here, what is happening, my dear friends? If you implement a get name function in employee, automatically it will be derived in the child entities. If you implement a get ID function in the parent class, automatically they will be inherited. But compute salary cannot be written in the employee because that need a job of this class, job of this class, and job of this class. Now let us see what is his main intention. Get ID is implemented in superclass. Yes. When it is implemented in superclass, automatically derived in subclasses. Get name is implemented in subclass. Okay. I can derive into child classes. Get name is implemented in subclass, not need not implement it because you can directly inherit it. Get salary is a function that's supposed to be written in the superclass, and that function you need to inherit into what? That function you need to implement into child classes. Why to implement? Because you need what? Jobs of the child classes. So write that function in the superclass and implement in the subclass because you cannot directly inherit because all the properties are not there in your superclass. Therefore, you need to depends on your subclasses. So according to this, the answer is 1468. That's it, dear friends. This is how you can answer the ER model to relational model. And in next session, we are going to discuss complete SQL consecutive series. Initially, I'm going to start with SQL with the constraints, then SQL with a select clause with the group functions operators, then after that joins, after that subqueries. This is the next 4 to 5 days class schedule only on SQL. After that, I'm going to start transaction management, concurrency control, and file structures. Then last I will discuss schema design because many of the students they wants to know initially these topics initially. That's why I'm starting SQL immediately. After that, TM, CC, file structure, then schema design. Stay tuned to Unacademy and stay tuned to my classes. Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel and use my referral code to convert your admission into Unacademy so that I can able to act as your guide. Many of my students who have learned GATE program and cracked the GATE examination with the help of me, they're also going to help you with in your work. So let us meet in the tomorrow session. Thank you very much for your support.